Hello students, in this video we find a difference quotient, that is f of x plus h minus f of x divided by h, where f of x equals x squared minus 7. To begin, I want to write down a few preliminary expressions, namely I like to write down both f of x and f of x plus h. So I'm going to write down f of x, which is x squared minus 7. And then I'm going to write down f of x plus h, which is simply taking x plus h, and let me highlight that. We're simply taking x plus h and substituting it into our original function. That means we are going to take the x plus h expression and put it into our function, and so it's going to replace the x in our original space right here. That is, f of x plus h is just x plus h squared minus 7. Do you see how x plus h replaced that x in that first spot? You just stick it right there in that spot, and that's going to be x plus h to the second power minus 7. Now we want to expand. And remember from our discussion in class that x plus h squared can best be thought of as a foiling process, or x plus h times x plus h. So x plus h to the second power is just x plus h times x plus h. And don't forget the minus 7 at the end. We're going to continue simplifying by using the FOIL process, that is first, outer, inner, last. And so I'll highlight that I'm going to take x times x, then do x times h times x, and finally h times h. So let's go about that process right now. X times x is x to the second power, or x squared. X times h is plus xh. H times x is plus hx. And h times h is h to the second power, or h squared. Carrying down that minus 7 at the end. Now, one more step in this simplification process, namely combining like terms. And we know that xh and hx are the same variables. In fact, xh and hx mean the same thing. We're adding two of them, and how do I know? Because there's an imaginary 1 in front of both of those quantities, and when I add and combine those like terms, I combine the coefficients. So I have x squared plus 2xh plus h squared minus 7. That expression is simplified as far as it will go, and so I'm going to put again to remind myself that f of x plus h is equal to x squared plus 2xh plus h squared minus 7. I'm getting tongue-tied. And f of x, remember that's our original function, is equal to x squared minus 7. So now I want to substitute these two expressions into our difference quotient. Recall, our difference quotient is f of x plus h minus f of x, all divided by h. And let me color code things to make it a little more clear. I am going to see that f of x right here is an expression that I'm going to have to substitute into the difference quotient right here. F of x is going to get replaced with the expression x squared minus 7. Let me go about doing that. Minus f of x, which is x squared minus 7. And notice I put parentheses around it because that expression is a whole expression that has to get subtracted. So x squared minus 7 is my original function, and that's going to get substituted in place of f of x. Now, f of x plus h. Okay, this was the thing that we worked out where we had to FOIL. F of x plus h, what is that equal to? Well, f of x plus h, if we look down here, that is equal to x squared plus 2xh plus h squared plus 7. And so I'm going to use that expression to replace right here into my difference quotient. Namely, I'm going to write x squared plus 2xh plus h squared minus 7. The whole thing is divided by h. And now I'm well on my way to doing this different quotient. Let me separate this so my work doesn't get too close together here. So in the numerator on my difference quotient, I have x squared plus 2xh plus h squared minus 7. X squared plus 2xh plus h squared minus 7. And then minus x squared minus 7. So I'm going to do a quick distribution and distribute that negative sign to each of the terms in f of x. That's going to give me minus x squared and then minus minus or plus 7. We have to be really careful about that double negative. Now let's see what we can combine. What do you see is happening in here? Well, I see that I have an x squared that cancels with another minus x squared. So that's good. And I see this negative 7 is going to cancel with this positive 7. Well, that's good too. And that's going to leave us with 2xh plus h squared all divided by h. And we're almost done. Do you see that there's a lot of h's in this rational expression? Now, in order to cancel an h from a denominator, or this monomial in the denominator, we need to have it appear in the numerator. In other words, there's a rule in math that tells us in order for h to cancel in the bottom, it has to also appear in every term in the numerator, and it does. I'm going to break up that fraction then to show you that cancellation. That is, I'm going to take my first term, 2xh, and divide it by h, and my second term, h squared, and divide it by h. To divide a polynomial by a monomial, we divide each term by that monomial. By putting it that way, we can see very clearly how h cancels from the first term and how h cancels from the second term. If I have two h's in the numerator, I will cancel one of them with the denominator. Where does that leave us? Well, it leaves us with 2x times 1, or 2x, and h divided by 1, or just h. Therefore, our difference quotients can be simplified all the way down to 2x plus h. And that's it. If you have any questions at all about the difference quotient or anything else, please don't hesitate to reach out. Good luck, everybody.